Hello, students, and welcome to the next lecture and the next module. This will be a section about electric charge and how non-moving static charges interact with each other. We're working in the Glencoe Physics book in chapter 20 in both sections. There are two sections in this chapter. I've uploaded a PDF of your textbook to the module, and I've made an editable PDF for these lecture notes. I will love some feedback about it. I'm still learning how to make editable PDFs. I think I fixed the problem of the very small text that we had last time, but I will appreciate your feedback as we work through this. So, in section 1 of chapter 20, our essential questions are: how can you demonstrate that charged objects exert forces, both attractive and repulsive? How do we know that charging is the separation of, rather than the creation of, electric charges? And what are the differences between conductors and insulators? In the electrostatics module in Canvas, I've also posted a virtual word wall that includes definitions of all of these vocabulary words, though we'll be looking at the definitions through the lecture, and you can refer to the textbook for more information about these new vocabulary words. The review word plasma is not a vocabulary word we've actually had yet. But if you've had chemistry or other physical sciences, you probably already know that a plasma is a gas that has so much energy that electrons have been kicked out of their home molecules and atoms, and they're sort of freely roaming through the gas, which makes the gas conductive. Our new vocabulary words are electrostatics, neutral, insulator, and conductor. So, first we will discuss evidence of charge. Electrostatics, as I said, is the study of electric charges that can be collected and held in one place, meaning they are not moving. We'll talk in our next module about moving electric charges and current, and that will be a different topic of study. Over the years, scientists have determined that there are two types of electric charges. So we've already talked a lot about this in our particle physics discussions. There are two types. It's plus or minus, black or white, however you want to define it. Benjamin Franklin called them positive and negative. There's nothing inherently positive about positive charges or negative about negative charges, at least in terms of our colloquial use of the term, but it's a way to indicate that they are two types and they're somehow opposite of each other. Two objects with like charges always repel each other, and two objects with unlike charges or opposite charges always attract each other. Sort of the rule of attraction and repulsion for charges. If you rub your hair with a balloon, it will stand on end because of the electrostatic force between your hair and the oppositely charged balloon. You may have had a chance to do that as a kid, and we'll look at some more kitchen physics with some experiments or demonstrations of similar. So again, this is review for us of particle physics, but all materials contain light negatively charged particles called electrons. In addition, each atom has a massive positively charged nucleus made up of a combination of positively charged protons and neutral neutrons. For a neutral object, and most substances under sort of normal conditions tend to be neutral, the amount of negative charge exactly balances the amount of positive charge. If you add energy to a substance, the outer electrons can be removed from the atoms. They can be sort of kicked out. An atom missing electrons then would have an overall positive charge, and any matter made of those electron-deficient atoms is positively charged. It's like you remove some of the electrons in the outer shells, and you can kind of see the residual extra positive charge that lies in the nucleus of the atom. Those freed electrons can remain unattached, or they can become attached to other atoms, resulting in negatively charged particles. From a microscopic viewpoint, acquiring charge is a process of transferring electrons. You might wonder why we're always talking about electrons when we transfer charge, when we charge an object or discharge an object. we'll talk about that in a moment, but it has to do with the fact that the electrons are in the outer shells and the protons, the positively charged elements, are deep inside in the nucleus. So if two neutral objects are rubbed together, they can each become charged. For instance, when a rubber shoe is rubbed on a wool rug, electrons are removed from the atoms in the wool and transferred to the shoes. The extra electrons on the rubber result in a net negative charge. The electrons missing from the wool result in a net positive charge. And this highlights the idea of conservation of charge. Charge is conserved. We are not in the process of charging an object, creating or destroying charge. What we're doing is moving electrons from one object to another. And in the process, we're giving an object either excess negative charge, or we're sort of exposing the positive nucleus of the atoms in the other substance. So that leads us to substances that can collect and accept charges. So there are two types of electrically interactive stuff. We call them conductors and insulators. And we define an insulator as a material through which charge cannot move or cannot move easily. That is to say that if I charge an insulator, a balloon is an example of an insulator, the charge I add to it, so the extra electrons, stay stuck where I put them. Or if I take off electrons from the substance of the balloon, the latex or whatever, I'm only taking electrons off of a particular area, and the neutral atoms elsewhere in the balloon remain neutral. The alternate is a conductor, and a conductor is defined as a material that allows charge to move through it or about it, around it. And metals are good conductors. In a metallic substance, there's this matrix of atoms or molecules, and the atoms and molecules have kind of a shared outer electron cloud, and the electrons in that outer electron cloud can kind of mix and mingle from one atom to another. So even though the metal might be neutral, the electrons can move around. That will become especially important to us in circuits. Metals are good conductors because at least one electron on each atom can be removed easily. Those electrons move freely throughout the piece of metal. So if I added extra electrons to a metal, those extra electrons wouldn't stay put in the place where I added the extra electrons. They would sort of push each other around and spread out evenly around the conductor. Under certain conditions, charges move through air as if it were a conductor. For example, the spark that jumps between your finger and a doorknob after you have rubbed your feet on a carpet discharges you, your body. In other words, you've become neutral again because the excess charge has left you. Similarly, lightning discharges in a thundercloud. In both of those cases, air becomes a conductor for a brief moment. Excess charges in the cloud and on the ground are great enough to remove electrons from the molecules of the air and create a plasma wherein the electrons can flow. So to review section 1, we wanted to demonstrate that charged objects exert forces, both attractive and repulsive. We wanted to know that charging is a separation of rather than creation of electric charges. And what are the differences between conductors and insulators? We've now at least used in context the words electrostatic, neutral, insulator, and conductor. And those terms are further defined in the word wall, the virtual word wall in this module on Canvas. We'll end this section with a video. And I think I will break this lecture into 2 pieces just to keep the video from getting too long.
Neat. Dear Tim and Moby, why do I sometimes get shocked when I touch a doorknob? From Sarah. Well, that's an example of static electricity, just like that lightning outside. Static electricity is the imbalance of positive and negative charges. It happens when 2 oppositely charged objects come into contact, or even very close. Where do objects get an electrical charge? Well, everything in the universe is made of tiny little particles called atoms. Atoms are made of protons, neutrons, and electrons. Protons and electrons have an electrical charge, while neutrons don't. Protons have a positive electrical charge. Electrons have a negative electrical charge. Normally, the protons and electrons inside of an atom cancel each other out. But sometimes an atom will lose an electron or gain one, leaving it with a positive or negative charge. Each of these objects has a neutral charge. Silk holds its electrons more tightly than glass, so when you rub them together, electrons can be transferred from the glass to the silk. The more you rub them together, the more powerful the charge will be. Because the glass rod ends up with fewer electrons, it has a positive static charge. The silk cloth, which now has more electrons, has a negative static charge. Hey, Moby, can you get me a glass of water? Psst. When Moby scuffs his feet along the rug, friction transfers electrons from the rug to Moby and a charge builds up. When Moby touches that metal doorknob, that charge is released and he gets a shock. I did not trick you. Ow! How did you...
See you for section 2.